This is a Jiku Power1D tutorial. After all models in a design are complete, you can run analysis. In Jiku Power1D there are two analysis modes, power and sample size. This tutorial considers just power mode. Refer to a separate video tutorial for sample size mode. Let's initialize a one sample design and then set its default model. When both models are complete, the analysis options become enabled. If one or both of the models is incomplete, the analysis model becomes disabled. Power mode can be selected using the drop-down box at the top. If power is not selected, please select it now. There are four options below the power mode: alpha, iterations, seed, and seed lock. After that, there are sample size parameters. Let's start there. For this one sample case, there is just one value, n, to choose. This is the number of observations in the single sample. The default value is 8, but you can change this to any value you want. Note that Jiku Power1D will not let you create a sample size smaller than 3 or larger than 500. Let's reset this to its default value of 8. Now let's go back to the parameters at the top. The first parameter is alpha. This is the type 1 error rate of the experiment and is usually 5%. The minimum alpha value you can set is 0.001 and the maximum value is 0.5 or 50%. Let's also return this to its default value of 5%. The next parameter is iterations. This is the number of random samples drawn from the data model on the left. The smallest value is 1,000, and the largest value is 100,000. Let's return this to its default value of 5,000. Jiku Power1D calculates power numerically, meaning that it randomly draws data samples from the modeled population, conducts a statistical test, and then saves the test result. It then repeats this process for many random data samples. This iterations parameter represents the number of random data samples. This is done to quantify the proportion of a large number of data sets for which an effect will be found. Indeed, this is the definition of statistical power: the probability that a true effect will be correctly identified in a large number of identical experiments. For the iterations parameter, there is generally a trade-off between speed and accuracy. When the number of iterations is small, like 1,000, analysis is conducted quite quickly, but the results are usually not stable. When the number of iterations is large, like 100,000, the results become stable, but calculation takes a long time. The most important point is numerical stability. If the results are numerically stable, then the selected iterations are okay. More about this in a moment. It is easiest to understand the next parameter, seed, by considering seed lock. When the seed lock is checked, the seed will not change after an analysis. So if I were to press run, analysis is conducted and the seed value stays the same. No matter how many times I press run, the seed will always remain the same when the seed lock is selected. If I deselect seed lock and then press run, you'll see that the seed increments to the next integer value after I press run. The seed sets the random number generator state. So if the seed is constant, your results will also be constant. Let's reset it to 0 and set the seed lock. If I press run, the omnibus power result here is 0.234. If I run analysis again, the result will be exactly the same. Thus, the seed allows you to precisely replicate results. If I now change the seed value and run analysis, the results will be slightly different. Let's reduce the number of iterations to see this more clearly. As the seed changes, the results tend to change. Not by a big amount, but there is some fluctuation in the results. So to achieve reproducible results, always select seed lock, and generally increase the number of iterations to achieve numerically more stable results. Last, let's switch to a different design to see different sample size options. I'll select the 2-sample design and then select the default model. In the analysis panel, you'll see that there are different sample size options than in the 1-sample design. The first parameter is mode. There are 3 choices: equal, absolute, or relative. Let's consider these 3 modes after considering the other parameters. The other 3 parameters are NA, NB, and NB over NA, or the ratio of NB to NA. NA is the size of group A. NB is the size of group B, and NB-NA is the ratio between NB and NA. In equal mode, NA and NB are equal. That's why NB is disabled, and so is NB-NA. NB will always take the value of NA, and the ratio will always be 1. In absolute mode, you can select different sizes for NA and NB, and the ratio will be automatically calculated for you. In relative mode, you can select the ratio, and NB will be automatically calculated for you. Note that NB will be rounded up to the nearest integer.